Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of representing linear proportional relationships. This is standard 8.5a in the great state of Texas, and we are using item number 20 off the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So, an online candy store is selling 3 pounds of fudge for $54.99. We need to find a function that best represents the relation between the number of pounds of fudge ordered X and the total cost in dollars Y. All right, seems like it should be pretty straightforward, but it seems like we've got kind of some interesting equations there. So let's see if we could just draw a picture of what exactly we're doing here. So we want to find the relationship between, so here's our independent variable, number of pounds. Okay, so pounds ordered, number of pounds ordered. That's going to be my X, right? So I'm just going to put X right there. And then Y, total cost. Okay, that's pretty simple. That's my dependent variable. Total cost in dollars. Well, if I want to order 5 pounds, how would I figure out the total cost? Well, I'd probably just multiply the number of pounds by the unit rate. Okay, so what we need here is going to be, we need our rate. So when we're dealing with direct proportion, it's going to be this K, this constant of proportionality, something that we looked at in 7th grade. Right? So we're used to this direct variation as Y equals KX. So if we want to find what the constant of proportionality is, right, this unit rate right here, that's pretty simple. We can just divide both sides by X, and we'll figure out what that K is. And let's see if it's on our reference chart. It is on the 7th grade one. We have direct variation, Y equals Kx, but they don't necessarily give us the constant of proportionalities, but it's pretty easy to derive that by dividing both sides by your X. So if I'm looking for that constant right there, then I just need to divide Y by X. All right, so what is Y and X? Well, Y is my total cost, so they've already given that to us, right? That's $54.99. So let's put that right here. And then what is my X? My X is number of pounds of fudge ordered. All right, so I know that I bought $54.99 worth of fudge. That was 3 pounds. So if I divide the $54.99 by 3, that should give me my constant, right? That's my unit rate. And I actually apparently don't even need to know what that is. Right? So this is what Y over X equals. Remember, Y over X equals K, which means I can substitute that in right there. Right? So that's going to be my $54.99. Now, if we were actually going to use this equation, we would actually simplify that, right? We wouldn't leave it as $54.99 divided by 3. We'd figure out what a good unit rate is. But yeah, that looks a little bit better. All right, so let's clean that up. So Y equals your unit rate, which is $54.99 divided by 3. That's your constant of proportionality, multiplied by X, the number of pounds that are ordered. All right, so that's looking like B there. Let's see what's wrong with some of these other options. So, yeah, look at A. They're multiplying everything, right? So the $54.99 by X is fine, but if you multiply that by 3, you're getting a unit rate that's like $150 a pound, whereas it should be closer to whatever 55 divided by 3 is, right? So that's going to be about 25. I'll call that about $18 a pound. That's about $18 a pound, but that's going to make it $165 per pound. That's nuts. Then subtracting, it's not working because we need to divide it. So our answer here is going to be B.